In section 3, we're dealing with slope-intercept form. To get to slope-intercept form, first we just need to review what slope is. So what is slope? Before we get into the algebra, give me the concept. What is slope? Like in words. Yes, that's more words, but like in real life, what would slope be? There you go, steepness. Slope is just steepness. Steepness? Why? Okay. All right, now in algebra we learn how to calculate slope, right? Like we have the steepness of the mountain compared to the steepness of the floor. The floor has no slope, but the mountain does. Okay. Yeah, everybody say steepness real quick. Yay. All right, so then in algebra we learn how to actually calculate slope. There's a bunch of different ways we can do it. If I give you a graph, how do you calculate slope? Rise over run. What you're really doing is you're finding how much y changes, that's the rise, and you're dividing it by how much x changes, that's the run. So we would call that the change in y divided by the change in x. That's what rise over run means. To calculate slope, if I give you a bunch of ordered pairs, how can you do that? We know that it's rise over run. We know that that's the change in y over the change in x. So how can I calculate the change in y with just ordered pairs? No. But now you're thinking. There you go. y2 minus y1 over x2 minus x1. That is the change in y. How much does y change? Well, I take the result and I subtract where it started. And I get the amount that it changed. How much does x change? I take the result and I subtract where it started. And that's how much x changed. And now there's one more thing we need to remember. Slope has a special letter that we use in algebra. What is it? M. So in general, we're going to use m equals y2 minus y1 over x2 minus x1. If you're given ordered pairs. If you're given a graph, you can use rise over run. Or you can pick 2 points on the graph and then use y2 minus y1 over x2 minus x1. Okay? We need to remember also where y2 and y1 are coming from in x2 and x1. They are from 2 ordered pairs. This would be x1, comma, y1. This would be x2, comma, y2. So with your ordered pairs that you're either given or that you pull off of a graph, you would assign one of the ordered pairs to be 0.1 and the other one to be 0.2. And it doesn't make any difference. If you do the math correctly, you should wind up with exactly the same answer, whether you call this one 0.1 or this one 0.2. Just make sure that you're consistent down here when you enter them into your slope equation. All right, what is the slope of a horizontal line? Well, that's an ordered pair. What is the slope of a horizontal line? A slope isn't going to be an equation. It's just going to be a number. What's horizontal mean again? Is it straight up and down or straight side to side? Side to side. Think horizon, right? Like the ground meeting the sky. That looks like this. What is the steepness of that line? Is it very steep? No, it's not. Therefore, the slope is 0. The slope of a vertical line. Now we're talking about a sheer cliff. Does it get any steeper than that? Can't get any steeper than a straight up and down line, right? So what's the slope here? It's undefined. In order for a slope to be defined, we have to have a change in x. Does x change at all? If I pick 2 points on here, like maybe that one and that one, does the x coordinate change? No. So if I go up to here, I get the same number being subtracted from itself. What would I wind up with in the denominator? Can we divide by 0? No. So that's why this is an undefined slope for a vertical line. You guys have to keep these straight. You have to know that a horizontal means this, and a vertical means this. And you also have to know that horizontal, meaning this, has a slope of 0. And vertical, meaning this, has an undefined slope. It's not no slope. This is no slope. This is undefined slope. All right, bunch of practice problems for finding the slope. If you need to, this is sort of the algebra of 1 version of this, then go ahead and write x1, y1, x2, y2 above your ordered pairs. In fact, let's all do that this time. And then if you don't need it after this, then that's fine. I'm given ordered pairs, so I'm not going to do rise over run. I'm going to do y2 minus y1. So I have m equals y2 minus y1 over x2 minus x1. And I'm just writing that down to be complete on this first problem. After this, don't have to write it down again if you don't need to. But I do need to substitute some numbers in here. So I have y2, which is what? y2 is 4. Minus. So I write the minus sign, and then I go looking for y1. What is y1? So it's 7. So I write 7 after I've written that minus sign in there. Okay, divided by, now x2, negative 2. Then I write my minus sign, and then I go looking for x1, which is what? It's negative 3. So I write negative 3. Do that. I've been doing this for years and years, and that is exactly how I find the slope. Why? Because it prevents me from making stupid sign mistakes. Write down x2, then the minus sign, then go looking for x1. All right, so now we have 4 minus 7, which is negative 3, divided by negative 2 minus negative 3. How do I deal with that? Keep, change, change. Keep the sign of the first term, change the subtraction to addition, change the sign of the second term. So now that's negative 2 plus 3, which is what? It's 1. So now I have negative 3 divided by 1, which is, so m equals negative 3 is my answer. Remember, you can do this either way. This was my point 1, and this was my second point. So that's why I wound up setting it up like this. But you can go the other way. This could be your first point, and this could be your second point. It doesn't matter. You will wind up with the same answer either way. So help me set up the second one here. What do I do? What do I do first? Okay, m equals. Then what? 1 minus 1. So divided by negative 4 minus. Okay. So it sounds like we called this point 1 right here, and this one was point 2. Right? Like I said, it doesn't matter. So what do we get up top? 0 divided by negative 7, which is what? It's 0. So m equals 0. Just because we have a 0 here doesn't mean freak out. 0 divided by anything is 0. You got to keep that straight too. Okay, talk me through the next one. Good. We will eventually. Finish writing the problem down. Good. So again, this is point 1 and this is point 2. So y2 is 1. y1 is negative 3. So I write 1 minus negative 3. Then divided by x2, which is that 7 right there, minus x1, which is that 7 right there. Now we simplify that down. What do we get up top? So this is keep, change, change. We get a 4 divided by 0. 4 divided by 0 is 4. 4 divided by 0 is 0. 4 divided by 0 is undefined. So our slope is undefined here. This is a vertical line. The x coordinates are the same, not a function. All right, go ahead and do the other three. This is just for practice to refresh your memories on how to do this. You guys are going to be doing it a lot. What's the answer on the first one? This one should be -1. Second one? 1. And the last one? 0. Good. Use the slope formula to prove that it does not matter which point you choose for x1, y1. How in the world can I do that? Yes, but I want to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. I want to prove that it does not matter which point you choose for x1, comma y1. What? Commutative property only works if there's no subtraction going on. Don't have any grouping symbols here. But you're thinking now, that's good. So by writing it like this, what I'm doing is I'm saying I have x1, y1, comma, x2, y2, right? And I've now written y2 first minus y1 second. So I'm putting this one down first and then this one down second. What I'm trying to get you to do is see that I can show mathematically that it never will matter if I put this one down first. So I wind up with x1 minus x2 on the bottom and y1 minus y2 on the top. We don't need numbers. We're using algebra. And that's the beauty of algebra. Once you prove something with letters only, then you've proven it for all situations. That's what I'm trying to show you right now. Because I've always said, doesn't matter what order you use these ordered pairs, you'll wind up with the same answer. Okay? The algebra now will show it. So that means I need to turn this y2 minus y1 into y1 minus y2. How could I do that? I got to turn this, I got to basically change the signs, right? If I multiply the top by a negative, will that change the signs of my y2 and y1? Yeah? So let me do that. But if I do something to the top, I also have to do it to the bottom. Okay, so now let's see what happens. What should I do? Like, what's the next thing that we should do here? So distribute negative y2 plus y1 divided by plus x1. Now we want to use the commutative property to rearrange the order that these are written. So I'll have y1 minus y2 over x1 minus x2. Is that what we were looking for? Now I'm saying this point minus this point, right? y1 minus y2, x1 minus x2. This shows me that now, algebraically, I have proven that I can write this in either order. In other words, I can pick either point as my first point. This is a huge idea here. And now you know that it actually does work, always. All right, some more review here. Sketch a graph for a line with the following slopes. So let me put some axes on here. And then we're going to come up with some graphs for a positive slope. What's this line going to be doing? How do I say that in words? Go that way. So it goes up from Left to right. Yeah, that's how I kind of taught that. So if I draw in a line that does that, that is a positive slope. It goes up from left to right. All positive slopes look like that. How about a negative slope? So from left to right, it's going to go down. If we're going up from left to right for a positive slope, we're going down from left to right for a negative slope. How about no slope? That is a horizontal line. M equals 0. That's no slope. Kind of like the floor has no slope. That's a horizontal line. How about an undefined slope? This one is a vertical line. Up and down, straight up and down. It has all the rise you want, but no run at all. Those need to be burned into the back of your eyelids. No easier way to check your graphing problems than to know that. Okay, what is slope-intercept form? Good. Y equals mx plus b. What do the letters represent? So what is y? Y is a variable. What is x? Y and x are variables. What is m? What is b? Good. Slope, intercept, form. This form gives you the slope and the y-intercept just by looking at it. All you got to do is solve for y. What is the equation for a line with a slope of 1/3 and a y-intercept of 0, negative 3? That's it. The y-intercept is where the graph crosses the y-axis. This number right here is where the graph crosses the y-axis. If I give you the y-intercept, then that is that number. If I give you the slope, then that is that number. It's that easy. To write an equation in slope-intercept form, we're basically bringing up the idea that we were doing in last chapter that had formulas and stuff, and you were rewriting it for a particular variable. We're doing the exact same thing here. So what am I supposed to do to rewrite this equation in slope-intercept form? Yeah, it's got to get into y equals mx plus b, right? So give me a 3-word phrase for what I'm supposed to do with this. Like what's my goal here? I'm trying to, what? Solve for y. That's all you have to do here. Write the equation in slope-intercept form. That means solve for y. So what's the first thing we're going to have to do? Yeah, you get the y term by itself. Save the division for last. Get the y term by itself. To do that, we're going to have to subtract 5x from both sides. And now we have negative 4y equals negative 5x plus 16. One more thing to do. Divide every little thing by negative 4. Divide this by negative 4. Divide that by negative 4. On the left, what do we have? Y equals. On the right, what do we have? It's positive 5/4. X minus 4. Good. That's it. It's now in slope-intercept form. Incidentally, what would the slope of this line be? 5/4. And the y-intercept would be negative 4. Okay? Fairly straightforward. Okay, talk me through the bottom one. What do we do? Subtract 3x from both sides. Good. So we have and notice how we're writing that. We are putting the x term first, and then the constant term last. That's how you should do it. Now what? Divide everything by 2, and I'm dividing every little thing by 2. I'm not drawing one giant line all the way across. That's where people make mistakes. 2y divided by 2? And you're done. Okay, the one with the fractions, what should we do? Add 3/4 x to both sides? Sure. You like working with fractions? Does it matter here? Multiply what? That's dangerous. Let's just solve for y. Add 3/4 x to both sides. And now what do I have on the left? We're almost there. What should we do now? Multiply by the reciprocal, which in this case is 2. So multiply both sides of the equation by 2. That gets rid of that fraction and leaves me with just y equals what? Yeah, it's 6/4 x. That's 3/2 x. Good. Always reduce your fractions. Minus 2. And don't forget to distribute to both terms. There's my answer. Just because it's fractions doesn't mean panic. You can still get through the problem. Next. Good? Nice. And I like how you remember that negative sign there. Way too many people forget that negative sign that's attached to that term. The sign goes with the term. Now what? Good. So that would be 7 over negative 5, which is the same as a negative sign out front. Negative 7/5 x minus 7. Yeah, plus a negative 7 is right. But then you turn it back into a minus sign. That's right. So minus 7, there's your answer. So that's how to write things in slope-intercept form. To graph a linear equation, if it's in slope-intercept form, it's really easy. If it's not in slope-intercept form, put it in slope-intercept form, and then it's going to be really easy. So what should we do here? Good. So let's put, I don't want a B, I want a P. Put in slope-intercept form. So we're going to add 2x to both sides, and now I have y equals 2x plus 1. Oh, what do you know? It's in slope-intercept form now. How do I graph something that's in slope-intercept form? Yeah, so I have my graph right here. We don't need to go to a table. We're just going to graph it. Start at the y-intercept, which is what here? It's 1. So on my graph, I'm going to do what? Go up 2 right here. Up 2 over 1 right here. From the origin, I do what? Yeah, that's what I'm trying to do. Where do I go from the origin? The y-intercept is 1. That's 1 on the y-axis right there. Now what? I go up 2 over 1 from the origin. From my y-intercept, I go up 2 over 1. So here, okay, be specific. Now what? Yes, do that over and over. I like to really put a lot of dots in. Now I'm out of room. What can I do? I'm out of room on my grid. No. Go the other way. Go back to the beginning and reverse it. Instead of going up to right 1, I'm going to go down to left 1. Get lots of dots on there. And now when I line up my ruler, I'm not going to have two dots really close together. I'm going to have two dots that are very far apart. Because I'm going to use this dot right here and this dot all the way up here to draw a very accurate line. So I take my ruler, I put my pen down on that dot, I swing my ruler to my dot, I come up here and check to make sure that my ruler is going to go through that last dot, and then I can draw my line. And my line has to go all the way through the grid that I'm given, and it needs to be straight. Put arrowheads at either end, and you're done. All right, let's get this second one so that we're set up in slope-intercept form. Subtract 4x, like it. Negative 7y equals. Okay, now what? Good, divide both sides by negative 7, each individual little thing, and I get y equals positive 4/7 x minus 2. Where do I start? Where? On the y-axis at negative 2, which is right there. Now what? The rise is 4, so we go up 4, and then we go to the right 7, which is all the way over here. Anything else I can do here? Reverse it. Instead of going up 4, I can go down 4. 1, 2, 3, 4, and over 7 to the left. 1, 2, 3, 4, 7 to the left. Now I have two dots that are farther apart, and I can draw that line in there. Very accurately, hopefully. Draw the line all the way through the grid with arrowheads, and you're done.